According to Albert Einstein, God doesn't roll dice. He didn't agree with the idea that everything is a chance or probability, but in the quantum world, nothing is certain. Everything is a game of chance. Take Schrodinger's cat, for example. If you were to lock a cat in a box with a flask of hydrochloric acid and a radioactive substance, there is a chance that the flask may break after an indeterminate amount of time, causing the radioactive substance to decay, killing the cat. While the box is still locked, you would have no idea whether or not the cat is still alive, so it is simultaneously both alive and dead. There is a chance of either happening at any time, but it is all probable and uncertain whether or not the cat will be alive when you open the box. Only once you see it is it certain. However, technically both outcomes did in fact happen, just in parallel universes. Quantum mechanics suggests the multiverse theory, where all possible outcomes that may happen do happen, just in different universes than the one that you are experiencing it in. The cat did die, but it's also still alive. Similarly, if you were to take a set of gloves, one right and one left, and send them at random to opposite sides of the world, no one will know which one went where. Of course, if someone were to open the box with the right glove, then they know for certain that the other person received the left glove. They're what would be considered entangled, and it is certain what one must be after the other is measured or discovered. This is an oversimplification of quantum entanglement. Quantum entanglement is the idea that once two particles interact, they are connected forever, no matter the distance between them. This concept often stems from the idea of the Big Bang, saying that all particles are connected or entangled in some way because we all came from the same explosion. Particles have a measure called spin, which is a measure of movement in the molecular scale. And if one particle here on Earth has a spin of +1, then whatever particle is entangled with it, however many light years away, it must have a spin of -1. But you won't know which particle has which spin until you measure one of them. Because these particles are connected, if one were to change spin to, say, +1.5, then the other would simultaneously change to -1.5. In quantum entanglement, whatever happens to one particle has a direct effect on the other particle that it is entangled with. In the quantum world, nothing can be determined until things are measured to an exact precision. But even that isn't certain because variables are always changing. I mean, you can't exactly measure where an electron is, just where it should be, and quantum mechanics would suggest that it can be in many places simultaneously. Even Heisenberg's uncertainty principle suggests this. It outlines that math has limits and cannot accurately outline every possibility. It's only a tool to help understand the universe, not solve it. It's all like an illusion, a very important and very complex illusion.